Let's start now.
Okay. So now you know the basics of Unity, the basics of Unity programming, the basics of how um, how objects interact with one another, and how to set up your scene, how to um, yeah, how to make the basic visual setup. And now we will move to the specialized part with scientific visualization and multimedia art. Today we will do more of the scientific visualization, but again, some of the uh, basic ideas are still common to both tracks. So that means that if you come tomorrow, you will have time to do the second part as well, the multimedia art part. Like I said before, the main difference will be in the type of data you will be manipulating. So here we will be doing something with scientific data if we have time, actually, because I first need to show you how to transfer this raw data, some numbers stored somewhere in a file, how to transfer them to screen in some way that makes sense. And yeah, so for that, we will use something called visual effects graph. So up until now, we've been programming using a traditional programming language, using C#, and a visual effects graph is a kind of program, but we will build it using a visual tool. And what the effects graph is doing basically is taking some data stored in your graphics card memory, and it can be texture data or vertex data. Vertices are like basically a mesh, some sort of mesh saved in your card, and texture you already know that's a picture. And instead of using those things directly as like meshes and textures, we will actually use the data stored in the texture. We will approach it as like some abstract just numbers, because then when you take your scientific data, you convert your scientific data to a texture, and then you decide you have a lot of freedom with the VFX graph of how to display that texture in your scene. But before we get to that, I need to show you the VFX graph itself. So a VFX graph is another object that it's called a visual effect. So we start with adding creating a new object of type visual effect. If it's there. If it's not there, because it's not in the default set of packages for the URP project we started, we need to import it from the package manager. But here we don't go to the asset store because it's part of the basic Unity packages. So you go to Window Package Manager, and here you need to change the repository from My Assets to Unity Registry. And inside Unity Registry, you scroll down and find Visual Effect Graph and install the Visual Effect Graph. After a while, something will recompile. And yeah, finally, you should get your visual graph effect package installed. So again, in package manager, you need to change to Unity registry, and then you will find the visual effect graph somewhere down in the list. Just let me know when you have it. Yep. Yeah. No, but you're downloading and waiting. Yeah. Okay. Got it? So everyone? Yeah. Yeah. Almost. Yeah, like I said, a lot of time Unity programming is actually taken by waiting. But yeah, when you got it, you can close the package manager. And when the package is downloaded and installed, yeah, no, but it's installing already. Yeah. Okay. So mm, the visual graph is based on the idea of manipulating particles, um, like some computational particles in the GPU memory. And so the primitive here is a particle, and a particle by itself only has one mm, property, and that's a position, and you can give it more properties like color, but you can also interpret the particle itself using a so-called shader. A shader is a short program that takes, for example, the position and color as inputs, and then decides how to display, how to render your particle. And it can be as really as a dot, but it can also be as a surface, as a cube or something like that. The idea here is that uh, you don't have just a couple of particles, you usually use a lot of them. So if you're for visualizing those like scalar or vector field, like temperature in a room, which you put on a 3D grid. If your grid is 1,000 by 1,000 by 1,000 cells, then you have a billion particles. That's a lot. Most graphics card won't be able to display that at once. So for large scientific data, you will also need to find some way to filter it so that your data set is small enough that your computer is actually able to visualize it. And then you of course decide what's the best way of visualizing your kind of data. So here what we will do is we will use either particle-based data. That really means that in our source, each particle, each computational particle has predefined, or like in the source file, we tell where the particle should be, and what color should it have based on some property in the file. The other type of data will be, like I said, something like temperature in the room. So you have a big matrix of numbers, and we will just like put it in a box and make it semi-transparent so we can walk through it and like be in that visually represented temperature or whatever. And at the end, we'll also show some special ways of manipulating this. So like putting a slice in the data so that you can move the slice and have like better view of some specific part of your data set. So ready? Fine. So let's start with the VFX graph itself. So now if your package is imported, you right click and go to create, and somewhere you will find visual effects, and you create a new visual effect graph. You give it a name. I don't know, small particles, so whatever you want. And you can drag it here to your scene, and something like this should appear in your scene. So you have those little particles. Each of them looks like this is like some color calibration target. They emanate from this point, which is actually situated at 0, 0, 0. They fly up and then they disappear. Yeah, so now we will modify the graph. Oh, yeah, and if you look at the object you have, so this new object, of course, has a transform, but the other component is the visual effect component. And the visual effect component also has this asset template, and the asset template is the actual graph that's being used. So the visual effect component is not the graph itself. The graph itself is this one of the properties of the visual effect component. So we can click edit, and a new window will open, or maybe it will open as one of the tabs. You can also detach the tab and have the visual effect in a separate window.
How do you detach it?
You grab the name of this top tab piece and move it like somewhere completely outside of the Unity window, and then it's detached, but it always stays on top. Yeah? So now if you see this basic graph here, there's also this little window called Blackboard. We will not use the Blackboard now, so you can hide it, that it's not in like, yeah. There's this small button Blackboard. If you click on it, this one disappears, and you can move in the graph again using your using scrolling on your touchpad or with your mouse wheel. You can zoom in and zoom out. And if you need to move the graph, you can either hold the middle button, and if your mouse doesn't have a middle button, you hold the Alt key, and while holding the Alt key together with the first button, you can move the graph around so that you can see better what's happening there. Okay. So what is in the graph? There's this is the basic pipeline of the graph, which describes the lifetime of your computational particle. So the first part is the spawn system. The spawn system creates the particles, generates the particles like with and initializes them with at position 0, 0, and no other properties set. Then you have the active system itself, and it's always made of three sections, or at least three sections. And there is initialized particle. So after the particle is spawned into the system, you give it some initial value. So this is kind of an equivalent of the start function. This is only run at the beginning when the visual effect appears. And then there's this, and you can see that here they set the velocity to the particle and lifetime. So we can already play with that. So if I, okay, so what's this doing? This spawn system has this constant spawn rate of 16 particles per second. So we are creating 16 particles per second. And here the system has some set capacity, so it can hold 32 particles at maximum. If you spawn more, then just like new particles will not appear. But that would mean that in 2 seconds we would fill the capacity. And for that, there's this set lifetime. So the particle has a lifetime between 1 and 3 seconds, selected randomly. So and that's set at the beginning. So when the particle is spawned, it's initialized with this lifetime. So let's say its lifetime is 2 seconds. That means that after 2 seconds, it will disappear. It will be removed, and you freed the capacity for a new particle to be spawned and put here. Also, at the very beginning, they set velocity to the particle, and we can already try, for example, to disable the set velocity. If you disable set velocity, they will just not move at all, and they will stay at 0, 0, 0. Or again, this is a random velocity, so for each of the components, it chooses a random number between the first one and the second one. So I can also, for example, set both in x to 0, and then you see that on one axis, the velocity will always be set just to this number. If I set like 1, 1 and 1, 1 here, they will emanate like along a single line. Or like, no, this will make them emanate along a single line. And with the lifetime, if I unset it, they will not be destroyed, but they disappeared. This is because this disappearance is all that there's another thing that's controlling them, and that's like in a later stage. So let's leave this as it is now. And so this is set at the start of when the particle is initialized. Then you have this update particle function, and that again is called at every frame. So if you want to modify the behavior of the particle, you will need to somehow do it here in the update function. And finally, there's this output function. And the output function tells us how the particle is rendered to the screen. And in this case, there's also, okay, so first it orients the particle. You see that there's this main texture. And so if I click again here on the small circle, you see a lot of like different small textures we can use. And if I don't know, I choose this, the particle can have a different shape. If you click in the search. Okay, once again. Yeah. Here, if you start writing particle, you should also get this default particle texture, and you choose the one called default particle system. Then they are like those shady dots. Then there's this set size over life function. If I disable it, they are all the same size. So what this was doing was that at the beginning, they start as small particles, and at the end, they get large. Here, under size, you have this little graph. If you click on it, it gives you the curve that is setting like at time 0, when the particle is born, it is small, and when it dies, it's large. You can of course change this, like for example, in the opposite way. And if you click in the middle of the line, it will give you another point. So you can create curves out of this. So you can have them start large, then in the middle, they can get really small, and then large again. And here is a different way of choosing some change in time. That's for changing color in time, and that is why they were disappearing, even if I set their lifetime to be infinite. And that's because here we are setting color over life. So if you click here, there's this selection of color over life. Okay, on both sides it's white, but let's say we change the end side to red. And then you see that they start white and the end they red. But there's also at the top, this is the selection of the alpha value. So when they're nearing, like over time, after some time, they disappear because their alpha level is set to 0. So if I put full alpha here, now they're being deleted as because the lifetime is deleting them. But if I unset this lifetime, you see that they just stay red and big and fly away to infinity. Now I already have 32 particles, so I cannot spawn new ones. Like again, if I re-enable this lifetime setting, they will kind of stay here. You can also, so if you have them start red and finish, yeah, turn the final alpha down a little bit and have them finish somehow yellowish, and this I would reset to something similar that was there before. And modify the velocity. Then, okay, I can also make more of them. So let's say I will spawn like 100 and turn up my capacity to 200. Yeah, I mean, if I were playing with this for another half an hour, it might resemble a flame. In fact, in the games, this is what this visual effect graph is very often used for, to simulate those like flame or fog or like some water effects and stuff like this. We will use it for a different purpose, but like as this is kind of like the basics of what the graph can do. Okay. I wanted to find some simple example from last year. Mm. Unfortunately, seems I'm missing some of my files got destroyed during some update, but okay, I can live with that. Hopefully. Okay, give me a second. Meanwhile, you can play with the main graph. Hmm. Okay, so let's go back to this example graph and so this defines the rendering pipeline of the particles. And the interesting thing about the VFX graph is that you can also do like general calculations that will influence the values of the parameters here. And those general calculations, you create like graph nodes that manipulate some numbers according to whatever algorithm you write here, and then the outputs can be connected to the nodes in the graph here. So let's say, like I said, we have the okay. So first, let's set the velocity to 0. So now the particles are being created like here, and they know that they don't move anywhere. And if I also unset this lifetime setting, then they will be created and they disappear because of this. So I also uncheck set color over life, and they're just being spawned and stay in place. So now I've generated 200 particles because that's the maximum capacity here. And I have 200 particles, but they're all at the same place. So what if now I want to set the position of the particle randomly, just like set the initial position of the particle, so they would be put on different parts of the screen or the scene, and just leave them there. So here into initialize particle, I can right click and, oh, sorry, not left click, so that it's selected, and press space. And I find into this block, I need to put some new setting. I will be changing an attribute, which is like some property of the particle. And in this case, I will be changing its position, but there's a lot of attributes in here. So what I look for is I'll use the search bar to look for position, and there's this set position attribute. So I click on set position, and initially it has 0, 0, 0 here. Okay, sorry. Okay. So I change it to something like 1, 0, 0, 1, 1, 1, and you see that it moves. The issue with this that when I change it here, okay. So you can like manually set the position, and there's another way that if I want each particle to be different, I have one option. So several options. So here, for example, right click here and create a new node, create node, and look for random. It gets you node called random number. And now you see that this generates a random number between 0 and 1. So I want to assign this number between 0 and 1 to one of the position coordinates, like this. I can get another random number generator. And connect it to the other coordinate. You see that this doesn't really look that random, right? They are in a straight line. That's because here in the random generator setting, we have options to like whether the random number is like each particle gets its own random number, that's fine. But also if the seed is constant, that means that all the random number generators with have this same constant number. So if I uncheck constant, the particles appear in on a plane, because one coordinate is fixed, the z coordinate is fixed, and the others are random. Yeah. Now I don't see much because the particles are close together, so maybe I want this random number not to be between 0 and 1, but like between 0 and 5. And now you really see that I am spawning particles at random coordinates with x and y between 0 and 5. Yeah? There's another way so let's say I put 1 here back. There's another way how to modify this number. So this is a function, and this is the output of the function, and I can of course feed the output not directly here to the graph, but to another function. So let's say I want to multiply this number by 5. So I right click, go create node, I look for multiply, and there's multiply float. So I connect the output of the random generator to one of the factors, and as the other factor I put 5, and the result is the same as here, because I'm just like getting a random number between 0 and 1 and multiplying it by 5 in this case.
I'm sorry, how do you stop particles from being spawned in a line?
Uncheck the constant in your random number generator. Does it work?
Yep.
Yeah, fine. So this number is hard-coded here, and like in the function itself. Of course, I can define it as some kind of like variable outside. So I right click again, create node, and I just create a float node. So I type float, and that creates a floating point number. Let's put 5 here and connect it like this. And then I can modify the number here. Okay, that doesn't seem that I did much still yet. But now we get back to the Blackboard thing that we have hidden at the beginning. So here I click on the Blackboard button, and Blackboard should appear like this. And here, if you click on plus, you can add variables that are common to the graph. So it's kind of like member variable of a class. And they can also be exposed to the inspector. So let's create a float. So somewhere here, yes, we find a float. A new float, we rename it to something like Y factor in this case.
Please, how the last one to do what we should click.
Yeah, sure. So, which part?
The last one about float. How to
Open the Blackboard. That's this button. Yeah.
Yeah.
And here, click on plus and find float. Yeah. And rename that float to, I don't know, Y factor. And now, here, I deleted this predefined float. And with the right click, I create a node and find a property. And under properties, you will have a list of stuff that's on your Blackboard. So you get the Y factor property, and you link it here to the multiplication factor. So now it's 0, because it has a default value of 0. But that's okay. We'll work with that later.
Could you create another multiplication factor?
I'll show you. So where did you get stuck?
No, I just missed the part where you were creating the.
No, the multiplication node. So everything here are so-called nodes. So you right click and you go create node, and now you have to find the correct node. So for example, multiply. Yeah. Will help all of you to get to this place. So where are you? Okay, what can I help you with? Yeah, just okay. That's okay. So you're getting a number between 0 and 5, and you're multiplying it. Yeah, okay. Fine. I mean, you multiply 1 times 1 times this. That's okay. So now if you open the Blackboard, this click. Yeah, okay, it appears somewhere far away.
A потім це робиться.
Why did it disappear? So now here on the Blackboard, you add a new floating point value. You can rename it something. And if you now delete this, delete, yeah.
I can understand.
And which node should we delete?
This is now reading the fold here, and then push it like. You don't need the first.
I feel like this is that.
No,
You should just move it higher.
Yeah. So now we're generating a number between 0 and 5. Then you're reading whatever is here in this fold. For example, 2 here.
Different mode where you can move down.
Then you multiply it and put it into the position value. Now you're putting it into all position values at once. You click here, so that's X, Y, and Z. So then, for example, only 50 things.
And you can look if it's anticipated.
Okay.
You can protect it so that you know where it is. Keep protecting. Yeah, looks like it's somewhere above the ground and not too far away. So now it should be visible when you start the image. I'll make that.
The size of the
Visual ground.
near the site.
Він десь створив все-таки.
Так, ось він створився.
Ні. Так, це буде particles. Подивися, де вони нормальні. Оце його можна далі перетягти.
Ну, ладно, це. That should be here.
Потім в ньому дивимося, що робить штуки, тобто воно дає створює таку максимальну
Just make it bigger.
Там вище.
You can detach it or like double click here.
Or you can click on.
Yeah.
Це можна брати.
So what's happening here is
Потім, щоб задавати ага, бачу. Змінювати колір можна залежно від моменту життя, а потім тут просто йдеш моди, поки ні, не там.
Ні, це так.
А тут поки йдеш
Ноди і operator multiply.
Це один мультиплей, а ще треба дати.
Okay, yeah, like the texture is find this particle, like particle.
Потім ти звідси крапочку перетягуєш у там set position. Там де пальці добре. Це тебе. О, є, так. Так, є set position, так, ну там де пальці.
Ні, я не повинен пробувати те, що потрібно. Maybe disable them in the chat. That was okay as well. Or like double click. Yes. Oh, sorry, not double. Instead of oh, sorry, 255. Like I always forget 200.
Це ж має бути. Це ж тут нам створити собі.
And now look if they appear.
Ну, він мав би створити.
Ні, він не створився.
To move it, you click. Or you also can click the right art and the download. I think either art or I find it more. Ну, це не всі ясно, що це може бути або lifetime,
Навіть щось вам.
maybe decrease lifetime from 3. Так і має бути, вона там до дефолтом малює, що виглядає як будівники.
Зараз подивимося. Половину камери знесу.
А, чекайте, тут можна камеру рухати і не вмикаючи анімацію?
Правда, кнопку миші.
Ні, в цьому. А, ну в цьому ти...
Так у мене вона.
Це просто треба обрати нову камеру.
Що ми? Що буде?
Ходити, я.
Ходити в сенсі.
Як ти ходиш?
Дивись. Праву кнопку миші затискаєш, position, виходиш. Отут.
Це повертати. Не буде. То що вертати можна так. Я знаю, просто не розумію ці проценти. Так, вертати, правильно. О, мене так вийшло. Можна вийти space, дійти до старих, то на весь екран повинен.
No. I don't know. No.
Ty defaultně už nie rozumím. Ale čemu? Tak třeba. To je defaultně. Třeba Verfahren, das ist schon eine gute Nummer. Да, ага, очень чувствую. Прям может поделиться. Не предлагаю на второго. Double break on the set. I was not sure about this definition, but it's also like this doesn't exist. Then you set it.
Maybe I can close this and do it again.
Yeah. It's probably sometimes. Oh. Yeah. Just click on the one. Like you can delete this.
Probably they don't get destroyed. Oh, but the name. I didn't know. Now it should be fine, but it should not be so. Yeah.
Yes.
No,
See it. You see it. So
Now it works.
yeah.
Because before that they were just all getting randomly created, and it was just covering all
And
the
now you can try to
volume and
Okay.
all the volume
this.
covered.
I have some
If you want them to
mistakes.
last longer, you just increase that number.
Wait.
Upper limit, and there are more. Also, you can regulate the speed with which they grow and the size to which it grows. All these effects. Mind the individual parameters.
I have also some mistake and volume in this screen.
So
Okay.
okay, click on the console or.
I need to improve this contact points.
For what? If you want them to stop being spawned, then yes. Why would you want to?
Okay.
That's for you? No, no.
Yeah, I just do it again because my previous don't work.
Okay.
Yeah. I mean, if it works, then just ignore it.
Maybe it refers to some field which is broken.
Yeah, that's what I was thinking, but I don't see anything like missing or Space. No. Click on the initialize particle and just like press space. Yes.
Я насправді не пам'ятаю, яка саме, да, set position була найкраще. Я не пам'ятаю елементи, що да, set position. Відповідно, там робити два рандомних генератори і передаєте один такий X. Але там зараз робимо так, що X генерується одним рандомним числом, а Y генерується рандомними числами перемноженими відповідно. Ну, щоб воно було більш закономірність, а не просто висі сторони. Ну, щоб зробити лінійну таку кількість. Ну, можна грати з передньою лінією. Як ви сказали, скільки зробимо генератор?
Can you please repeat again how we do by factor? It's effect too.
So you need to go from Blackboard plus float. Yeah, and you can also click on the arrow here and give it some default value different than 0, something like 2 or whatever.
Потім просто вибрати, гамму, від чого не приймати. От ви вибираєте якусь думку, наприклад, це, а то, так, коротше, треба розібрати, так, можна так і залишити. Так, і от, наприклад, в такому діапазоні буде мінятися. Тепер ви, якщо зараз галочку запускали, що буде мінятися, тепер якщо ви запустите, у вас буде перехід від блакитного. Але воно слабко видно, але можна зробити яскравіше якось. Вибрати сильніший колір і час життя більше поставити. А пару стоїть, да, можна я зробити там 2, а Б зробити. Тепер поняття ще колір. Ставте якийсь сильніший, синій. Ні, вам треба знову не вкріпити. Нижче, там виходить. І вибрати якийсь синій. А іншої сторони ви можете теж посунути, до речі, що можна робити. Це так як було.
So everyone got it somehow? Got it?
And now she disappears.
What did you change? Yeah. If you go back. So if you set the infinite lifetime, that's fine. But in the default graph, if you go down, the color at the end is transparent. So they are there, but they're completely transparent. So if you change the last point, yeah, like this, yeah, this is fine. Now the end is full visibility. So you can close this. And now if you uncheck this set lifetime, then they will keep existing, but since they have this velocity, they will fly to the top, and at some point they will just fly away.
Okay.
So you could also disable the velocity, and then they will be at the same place all the time. And this is actually what we will want for the visualization, because we will read the position of the particles directly from the file, and we don't want them to move on their own.
It's like the size of the particle. Yeah, I mean, not the speed of the changes, but the maximum size.
Right.
By the time.
Yeah.
No,
We'll get to that. I mean, we'll get to that more in the art part, but.
They start overlapping more because they have this big size, big time. And also they're growing faster because they change it. So you can change it so they grow first small but then large, or you leave it the way you like.
Okay, so now you know at least somehow how this works, how the things change. So while I was adding this factor here to the blackboard, instead of putting it directly in one of these functions, is that now if you open, now if you go to your scene, select this object, you see that you have the property exposed here. So you can actually change it from the inspector. If you did it exactly the same way as I did it, you will notice that changing the value in the inspector is not doing anything. And the reason for that is that in the graph, we actually put the position setting to initialize particle. So it was run when the graph was initialized, and then it never changed. Now, if I so my factor should be 4, but it still looks like it's 2. If I hit play, it will change because Unity will restart the graph. Yeah, you see it's bigger. But then it stays at 4. Now, if I change it to 2 again, nothing happens. I would need to hit play. Now, of course, it will remember that old value still. This is not that much of an issue when you create a graph and when you really know that the position of the particle should be set at the beginning and never changed. But of course, if you would like to change the position of the particle during the game or the visualization, during the run of the visualization, you would need to set the position not here in initialize, but here in update. So if you go to update and press space, and you again set position, you find the very same block. And again, I here click on the triangle so I can get to the individual parts of the vector and reconnect these here. Then I can delete this initial position setting because I don't need it. So here, press space, find set position, put set position here, and then open the vector and reconnect it from the one which was an initialized particle and reconnect it to update particle. Now, of course, there's more computation being done at each frame, because at each frame you are resetting. Oh, yeah. Okay, so we also put this random number generator here, which is not constant anymore. So at each change of frame, we are generating a new random number and setting that new random number as the position of the particle. So it should do something like this. And also when I go here, now of course, this factor will immediately change what I see on screen.
And what should we delete again in the right?
Oh, well, okay, I already deleted it, but originally, yeah, no, set position. Originally, I had the set position here in. I mean, you can keep it because it doesn't really matter. You set the position at the beginning, but immediately you change it here in update at every frame.
And how do we make update particles so that it has the position?
So you can right click and then there will be add new block, or you can just press spacebar and it will create
Yeah,
new block.
create new block,
Then you start
or
typing like to find what you want to add. In this case, it's
Add
that
position.
okay? No.
But my settings are it's now just a line. Again.
Yeah, you have to click on the triangle because now you connected the single number to all three. Yeah, yeah. So just set one of them. Yes, yes, yes. And this multiplication factor is, you see here, your multiplication. Yeah, yeah. You can change it and you immediately see the change. And of course, the same way as we are changing the value in the move script or whatever, you can also, from a script, you can also influence the value. You can also change this value from script, of course. Yeah.
But can you explain? I do it, but I don't absolutely understand what we change and why particles
Okay.
have another.
Okay, so
I don't know.
let's say I disable this. So what's happening here is, first in spawn, I create the particle. The particle gets created at 0, 0, 0 and has like no color, no like other interesting properties. Yeah. Then in initialize, I can, for example, give it some like this. Okay. So when the particle is born, I can, for example, set some default position for it. Yeah? So the particle is spawned, it's created in your graphics card, actually. And here, yeah, you can give it some initial value. So like the start function, something that happens when the visual effect appears on a screen. And then at each frame, I can also modify this parameter. So like here in update particle, if I'm randomly setting the position, so what happens now? I'm at each frame, I'm setting the position to some new value. How do I generate the value is controlled by the graph here. So I generate a random number and tell that the x coordinate of the particle will be that random number. Here I generate another different random number. I multiply it by whatever number I get from the inspector and set this as the second coordinate. Yeah. I don't know, I can also and this just yeah, I mean I can create a third random number generator, and now they will randomly fill a box with sides 5, 1, and whatever number is here. Okay?
And it's the first case, and in this case, we just do first position of particles, yes?
Again?
What change with the first case we do when we change in internalize particles, and now
Oh,
when
yeah. Okay. Yeah, because if you do this in initialize particle, then it only happens once. So at one point in time, when I put the effect on the screen, I say this particle will have a random position, but a single. I say you will be at position 5, and it stays there for all the time. I mean, 5 was chosen randomly, but it stays. But when you do it in update, then at each frame you generate a new random number and change the position.
Okay.
Okay? Yeah. Okay.
You called by factor. What was it?
Yeah. So this is a way. So you have this multiply operator here, and if I delete this connection, I can just here I can directly put the number by which to multiply this random number I got from here. Okay? Yeah. How do you create this?
Huh?
How do you create this? Yeah. Okay. So that's yeah. So here I'm multiplying by a number which is defined here in the graph. But maybe I want to change that number from the outside, from a script or something. So then I need to have a variable that I can expose to the inspector. How I do it is I open the blackboard using this button here. And on the blackboard, if you click the plus sign and find a float, like whatever you define here on the blackboard, if it's so-called exposed, then you can set this variable from the outside. You can set it from the inspector or from a script. Okay? So if you create a variable here, then in the graph, if you right-click, do create a node and find a property, then you see this property y factor or whatever name you gave it. And this is a number which is coming from the outside and which you can connect, not here, here, yeah? Okay? Okay. So what else can we do? Of course, we can use some different output than just this default particle. But maybe let's get a new graph for that. So I close this graph and
close up, yeah. Close up this effect.
Yeah, close that effect graph. I mean, you don't need to close it. I just did it. If you have it as another tab, it doesn't really matter. So here I go and create visual effect. I call it, I don't know, boxes. And again, if I do it like this, from right click and new visual effect, then here I need to create the graph, the new asset template, because I don't have it here. So I call it boxes. And again, it gave me this default and
yes, now it will be cluttered and move this, yeah, and both boxes effect.
So let's say I want to disable the set size overlay. I want to disable set color overlay. I also Okay, no. I will be completely deleting this later. So let's keep the random velocity. Why not? The lifetime, okay. Let's also add, like here, to initialize particle. Let's find set size and set it to 0.5, something like that. 0.3, something a little bit bigger. And then,
Can you repeat, please?
yeah, okay. Here in initial, okay. No.
Yeah, initial.
Yeah. So at set size. Set size, set it to something a little bit bigger, something like 0.3. And now we delete this output block completely. So we don't see anything. And here, from this small circle, we make a new connection. So you drag with your mouse to the empty space, release, and we put something like output particle mesh. And
delete output particle one.
yes, delete. Just select the whole output block and push delete. And
why do we change? How do we change the size?
You can do it, for example, in initialize particle. You find the set size block, and
Oh, yeah.
So output mesh, it can be lit or unlit, doesn't really matter. Here again, you can choose which mesh. So I don't know, let's say it will be a cube. And we should also here change the texture. And I hope it is here already. Yes. And you should find this white 1 pixel texture. If you type white, it will be white 1px. So select that. Yeah, okay. From mesh, for mesh, I've picked the cube. And for the texture for the mesh, I've picked this white 1 pixel. Okay. Well, in output,
Texture is
what?
What texture?
White texture. White 1 pixel. Yeah.
Що зробити? Зробити, якщо побачити.
Great.
I don't see.
Тут треба, можна написати на
Okay. Sorry.
white one.
So for the texture, choose white 1 pixel, and for the mesh, choose cube.
Треба новий. No, it's almost just a little bit of and we have a lot of cubes.
Okay. Okay, so now I will do some more modifications to this graph. And so again, I disable this random lifetime. I also disable the velocity setting, or like I completely delete it. So now let's see what's happening. I just have the cubes like at 0, 0, 0. What I will want to do now is to put the cubes in some position according to some predefined algorithm. And for that, what I can use is the fact that each of the cubes, each of the particles have their unique number as they are generated, and I can get that number using a node called get attribute particle ID. So if you write particle ID, it should give you get attribute particle ID. Yeah. And so if you get this get attribute particle ID, and here I put it into set position, so if one of the position values will be according to the particle ID, then the particles are then positioned as like 1, 2, 3, 4, 5, etc. Because the particle ID goes from 1 to the maximum capacity of the particles I have there. Or maybe they go from 0 actually. So it starts at 0, 1, 2, 3, etc. Okay. Now, let's say I want to put my particles on a grid. And what I have is the single number, the position. What I want to do is, so now I have 32 particles here. So I want to put them on a grid of 6 times 4.
5.
5.
Plus 2.
What?
6 times 5 plus 2.
That's not what I really want. So
Change it to 36.
or
Make it
no. What's that? That's 8 by 4. Is it 8 by 4?
Yeah,
it's 8 by
it
4.
is.
Or we can
I thought
put
you
it
wanted to
64.
like,
No, you know what? let's not do difficult mathematics like like multiplication here. Let's 64. That's 8 by 8. That I remember. And so now if we want, so what we want to do, okay, yeah. First, what we want to do is to position the effect so that we can see it. Yeah. So I take the boxes, put them somewhere here. So now I have them in line, and they like at 1, 0, 1, etc., etc. What I want to do is when I reach 8, I want to do kind of like a line break, and like start from 0 again. It's not very difficult to write on paper what I like as an equation, what I want to do, but it's kind of weird to do it in the graph. So what you need for that is you need the mod operator. So like the remainder of the integer division, and then you need the integer part of the division, and the integer part of the division will be your y coordinate, and the remainder part of the division will be the x coordinate. Yeah. So let's see if we can find this stuff somewhere in the notes. So modulo operation, yes, that's nice. That's exactly what we wanted to have there. Okay, now it says float, but of course we will be doing integer modulo. But you don't have to change it by hand like I did. So yeah. So of course, modulo 1, the result will always be 0, but we want the division to be done modulo 8. But I still have 64 particles here. It's just that it's like always 8 particles at the same spot. And
This model thing.
You right click on that.
it's in your yeah, right click, create node. Right click on in the free space, create node. You get a modulo operation.
Just start searching like first times.
Then we get the divide operation. And we divide the particle ID by 8. And of course, this won't work. This is not what I wanted. Because now you see that they're not in line. But here I need to take the integer part of the division. So I also need to create a node, just plain integer or floor, just to be like mathematically correct, let's say. So I get a floor, and if I floor this operation and connect that as the y coordinate, I have them in a grid.
Can you do size more big?
What? This? First.
How did you make it so that there are empty spaces in between the boxes?
Ooh, okay, so that of course depends on the size of the box. If this box is too big, then they will touch each other. And if you want to scale, what you can also do is to scale the position, because this is getting an integer number and converting it to a 2D coordinate. Yeah, so I have like numbered particles from top down. If I don't like how close they are, or how far they are, I can, for example, create create two flows here. Distance x, and I mean it will be a factor, but distance y. And I don't know, maybe I want to put them closer together or like further away. And of course, then you can
Boxes.
again.
What category in boxes we need to choose now?
Float. And I put a multiply operator here and another and another. Again, you can of course always like select more of the And I will delete these connections. And first I'm going to multiply. Another way to, instead of creating a node by right-clicking and clicking create node, you can also go from the connection point and just drop the connection in the empty space. And then it will tell you what could possibly go there. So we want a property, and here we want to connect the dist x property, and here we want to connect the dist y property, and I connect this to y, this to x. And now you see that mine are closer. And so if I put 2 here, they're further away. If I put 0.2, they are stuck together. So now I created just a brick of walls, a wall of bricks. And this is actually useful for the visualization part already, yeah? Because I have a grid, and on that grid, I can put some numbers, whatever the numbers are from my simulation or whatever. So, yeah. And you also see how they like appear gradually. That's because my spawn system is just like creating 16 particles per second. I could choose a different spawn system that just makes the particles appear all at once. But yeah, just that you understand the basic concept of how we're actually getting there, how we use the computational particles to display some predefined structured data. Because
Yeah, maybe let's make a short break now.
yes.
A lot of new information.
Yeah.
Graphs.
So just let everyone finish, then we will have a break. I will just like shortly try to explain if you have any questions to what we did.
Ідея зрозуміла,
Ну, якщо це треба, то питання.
So yeah.
Тут мійка.
I mean, for change capacitors, like if somebody is one, we're going to see
А це час життя, одна секунда, ну, типу, воно спавнить, зразу ж зникає.
Ні, принцип просто, що позиція додається.
А, позицію солодні. Я думав, що ви через це забрали. Можна спавнити, наприклад, там по 16 частинах. А, ну так, якщо всіх одночасно спавнити, то так. Краще
You
продати.
still have the random lifetime on them, right? Or like no, it's fixed.
It does change its coordinates.
In lifetime. No, yeah, you have set lifetime. So if you disable this, the set lifetime, disable it.
But then they will repeat. It will just cover all the.
No, because we go back to the graph. There's this important thing. Go up a little bit.
Yeah,
the capacity.
Yeah. Oh, yeah, that makes sense.
That's the thing that the capacity is the property of the graph itself. It's a shader, and the capacity is really a buffer in the shader, which is just the plain C array. So it always needs like there's no downside to that. The capacity is always set. Like you cannot have the same graph and just like change the capacity from the outside. When the graph gets compiled, the capacities are compiled in. That's like unfortunate for some. I mean, like if you want to graph with different capacity, you just like need to really compile a new graph. That's something.
What I've meant that, yeah, probably just run individual, the capacity is limited.
Yeah.
After that, it doesn't spawn required. I meant that you were making like a snake, so to speak, but now because they don't have the right time, they just fill this grid and that's it.
I need two or one.
With twice there,
Yeah.
and like you don't know why, or
I don't know. I need to have this, but or no.
we just have it twice here.
Oh,
Yeah.
I need the light one.
Yeah, or you can go to the properties, and you can change here, for example, if you change that to, I don't know, 4.2 or then you will have one small and one big. But again, since now you are setting the position in the initialize function, then you have to restart the graph. There's another way to restart the graph, and that's the quick play. Or stop and play. Stop. Play. Oh. Yeah, just like hit play and stop. Like and put it in the.
Oh yeah.
Yeah. Now they should be. Yeah, and so you got it. Yeah. Okay. Is it clear at least somehow? Yeah.
Nice,
Yeah. Unfortunately, but yeah. Okay, fine.
I remember last time we were making it 640 by 480, maybe for this part makes sense to reduce resolution. So that the texts are bigger. If we decrease, well, maybe not 640, but at least like 720p. You remember we were doing that?
Yeah, maybe
last time.
we were.
Just for this part. I mean, the rest it's not as crucial, but here it's indeed some parts are very small.
Yeah, okay. I mean, like for the scientific visualization, we're done with that anyway, because now we will download the big graph and start putting the data
The
in.
K0.
Yeah. No. The
K0 is
K0
out,
stuff.
yes.
Yeah. So now the ones I wrote.
The script to import data.
Yes.
Yeah. But still, you would need to operate a bit with this.
Yeah. That's hard. I mean, yeah. Okay, so now it would be best. You'll need to download some graphs, pre-made graphs, and yeah, that so I sent them to the Telegram group last year. So let's hope they will work this year as well. So if you open the Telegram group and go to scientific visualization channel, or it's not called channel, I don't know, topic, scientific visualization topic, then you should, the last 6 files, So we downloaded them. Apparently already downloaded today. I cannot create a new folder from here.
Just click in the empty space.
Yeah.
Там ці персоналі вирізати останні файли, наприклад, positions.
And they filter it.
So there's this positions, volume, and operators. And for now, just download them somewhere.
Я не бачу, де вони. Ну так, але я не бачу scientific visualization. Okay.
It is downloaded.
And which of those files do we need?
You find them in the Telegram group,
Yes,
in
yes.
scientific visualization, and like all 6 here and then.
We should put all of them into assets.
No. Only only the first 4, not the zip files. With the zip files, we'll do something a bit different. So first, keep the zip files out of the main folder, and I'll show you later what will we do with them.
And assets.zip. Also, we should also download. Assets.zip file sent by someone to someone else. Should we also download?
No. This is just those which I sent. And so before we get those files in Unity, I will extract these 2. I will unzip the files. And first, let's look at this cube files example, because that will show what are the source files that we will be using in the script. And again, because scientific data comes in many different formats, then of course you will never have like one solution that works for everything. I mean, you can, like Paraview, for example, works for almost everything, but it's also like a lot of work to create software that can really handle everything. So here we take a different approach in that we have this idea that we have our own file format. We don't really aim to provide some kind of framework that everybody could use. And we will be just focused on getting our data into a VR headset. That's basically the goal of the scientific workshop part. And for starters, I will use this cube format because you can find a definition somewhere on the internet. I think they call it something like Gaussian cube format. Yes, Gaussian cube format, and we say that it describes volumetric data as well as atom positions. So volumetric data, as they say, it's straightforward. One floating point number for each volumetric element. And volumetric elements are on a 3D Cartesian grid. And here's the yeah, okay, they to them, the atoms are in the header, but there's like header with some metadata that gives you the size of the axis and like the number of atoms, etc. And then you have one line for each atom consisting of 5 numbers: the atom number, charge, and XYZ coordinates. So that's particle data. Like on each line, you say my particle is here and has like 2 parameters. And for volumetric data, you have a predefined Cartesian grid. So you don't specify the position for each of the elements because you know it, you can calculate it. And you only give one number for each of that elements. So in the end, what it looks like is those for, this is the metadata part. And here you have 3 atoms. And so this is the atomic number, charge, and the position X, Y, Z, X, Y, Z, X, Y, Z. And this is the 40 by 40 by 40 floating point numbers. Like what exactly is each of these numbers, you just like read here. And if you will have your own custom format, then of course, like for example, the number of like you need to know the metadata, the number of elements in each row, or like the size of the matrix and all that stuff. But we'll be using the cube files, and this is an example cube file. Example. Example cube file. Example cube file. So here we have 128 atoms on an 80 by 80 by 80 grid. So there will be 128 lines here. You see it's all just beryllium. And here it's 80 by 80 by 80 numbers here. So we just like read them one after another. And what we will then want to do in Unity is to, like we did this grid with boxes, but this time we will have a 3D grid of boxes. So the calculation of the positions will be a somewhat more difficult graph. And also 80 by 80 by 80 might be too much for some of the older laptops. Well, probably everyone here should be fine, but just like in general, you might need to skip some of the elements. So of course, it would be nice if you could specify, let's say, the maximum resolution of your displayed grid, and then just like get the parts which are like kind of like, okay, we will not be doing interpolation, but we will just like look. I mean, we could. It's not that difficult in our case, fortunately. But like we will look at the nearest point and just get that. About the interpolation, one thing, in order to get the numbers there, we will convert our cube file to a texture. A texture is a binary format originally meant for images, but that was like kind of this invention of using GPUs for scientific simulations and computations. But someone realized that in the texture you don't need to have like an image of like some real picture. It's just like numbers, and you can then manipulate the numbers using the algorithms on the GPU. So we will be kind of doing this. So we'll read the texture, but instead of applying the texture to some object to actually see it as a picture, we will just use the numbers that define the pixels now in the textures, read them and use it for something completely different, whatever we want. For example, to set the positions, yeah, or set the colors in this case. So this will be like kind of similar. But the first thing would be to create this 3D grid, and the second would be to, according to the 3D grid of our particles, to go to my point in the 3D grid, look into the file, and grab the specific the specific element from the texture which is closest to my cube, like little cube, yeah, or my volumetric element. It sounds like a lot of work, right? Fortunately, you will not be doing anything of that because I already have those two so-called VFX operators, value to color map and index to UVW. What's a VFX operator? So what we have seen here is a VFX graph. And an operator is basically any of the nodes that has some inputs and outputs. And you have a lot of predefined nodes, but you can also create your own. So I can, for example, take, let's say, okay. So my inputs, let's say I want to turn this. So what's this part doing? This part gets in the ID of the particle, that's the input, the distance between the particles in one direction and the distance between the particles in another direction, that's the inputs, and the outputs are the coordinates, the positions for the particle. So maybe I want to reuse this thing many times, or I just want to hide the details about it. So I select all the parts which are not the inputs and which are not the outputs, right click, and click Convert to Subgraph Operator. And I call it something like index 2D. Save. And you see that it became just a single box with 4 inputs. The inputs are named after somehow like the names of the inputs are somehow deduced from the original inputs. You can rename it later. And 2 outputs, parameter and parameter 1. Yeah.
How do you do this again?
Select all the everything that is not the input. So inputs, in my case, I had 2 numbers and the particle ID as inputs. So I'll select all of that, right click, and do Convert to Subgraph Operator. And then you need to reconnect the outputs because they got new names. And this is doing exactly the same thing as our previous graph, but now the details are hidden here in this subgraph operator. And if you want to change the subgraph operator, you would then right click and go open subgraph. That's one option. Or if you look into your project, you will see that there's this new index to the visual effect subgraph operator which appeared in your assets. Yeah. And if you double click this new asset, zoom in, zoom out, then this is what it looks like. It takes in 2 integers that were the particle indices and 2 floating point numbers, which were the distances, and it's the same graph as we had here, and these are the output parameters. Yeah. So And you see that it's still doing the same thing as before. So, did it work for you?
I did this. And
Yes.
then I.
Yeah, that's fine. Right click. Open subgraph. Yeah. This is the this is the part that you converted to subgraph.
Yeah.
Yeah. Yes. So if you go inside, right click, open the subgraph, enter subgraph, enter. Yeah. Okay. And this is what we had there before. It's just like the one piece of the graph. Yeah. Oh, it's okay. No. What you did is that you also put the particle index inside the subgraph. That's okay. If you right click on the subgraph now, right, and open subgraph, you see that you have this get category already in here, yeah? And you're only getting those two distance variables. But that's okay. Like maybe you wanted to do that, maybe you didn't, but it doesn't matter. You got it?
How can you make an input that's like input? No, I think
You can go.
Can you make an input that is like in the public events?
Yes. You need to open the blackboard. That's the yeah. And here plus float or whatever type it should be. So, okay. How do you do that? Why do you still have those here? How did you do that? No. You need to select. So those were the inputs, yes. I just move them away a little bit, and then you select, and this is what you want. Yeah, convert to some kind of operator, and give it a name. And reconnect. And now it should do that. It works as before, but if you here go open subgraph, you see that it's been hidden in the subgraph. Yeah. I don't know which one was it. This one. You're good?
Yeah.
Fine. Okay. So instead of creating all these subgraph operators from scratch, you can go to the downloaded files and get this volume asset, this index to UVW operator, the positions assets, okay, as well, and the value to color map operator. Drag and drop it here, and you can explore. So if you double click on the index to UVW operator, so what is it doing? You see that there's an index, some integer number that's getting in, that's the particle index. Then you see several division and modulo operations and some conversions. There's also this max X, max Y, and max Z. And the output is something called UVW. And yeah, this operator converts the index and the coordinates like the maximum size of my box, and converts this this index and the maximum size to the final coordinate where I put my cube.
I actually haven't seen it. Maybe I don't drop it, but I don't have it.
It should be in your asset folder.
Okay, depends on what you call normal, I guess. Okay, I just like disable the notifications somehow.
Assets, folder assets. Yes.
No.
And now when you click there, it should be.
Oh,
Yes.
thank you.
So if we put a particle ID here, what we get out will be the position of that particle in this 3D coordinate system. Yes, and that's already enough to build our first visualizer. Not directly for the cube files, because that I will have to show you tomorrow. Because, okay, so one piece is missing. How do I get the cube file here? And as I told you, I need to convert the cube file to a texture. And I have a script that is doing that. And like, I can show you tomorrow a little bit how it works. But like, if you're not a programmer, it probably won't tell you much. And if you are a programmer, then it's probably easy if you just open the script and go through it yourself. So I will just like briefly show you how it works in case you would like to use it for yourself. But what we also imported is this volume file. Click on the volume file, and you already see here that it's some sort of cube with like some values, some colors. And this is actually what the output of the conversion script, which accept those cube files, so text files as inputs, and gives you a texture, because this is a texture, a 3D texture as an output. So a 3D texture is like you know, a 2D texture is a picture, and a 3D texture is like a bunch of pictures on top of each other, basically like an MRI scan or something like that. Now what we want to do is to take this volume file, which is 80 by 80 by 80, and sample from it.
Attention, the air alert is over. May the force be with you.
Great to know.
Attention, the air alert is over. May the force be with you.
I play with the volume tomorrow probably. So yeah, I mean the feeling's still there. Like during the alert, like I don't think about it at all. When it's over, I get angry at the damn Russians. So yeah, cube files, volume files, yeah. The sampling we will okay, I don't have it here, so we'll probably do it later.
What do you mean by sampling?
So maybe okay, 80 by 80 by 80 is not that much, but say your initial data would be 1,000 by 1,000 by 1,000. That's a huge texture, and you won't be able to visualize that in the VFX graph. Probably not. Maybe this computer will be able. It has this NVIDIA RTX 3080 GPU, but like on the notebook, no chance. So what you want to do is not to take every data point, but for example, every 10th data point. Yeah. So by sampling, I mean taking just like every 10th data point in each direction. And the way it's implemented in this sample graph is actually yeah. Okay, so why is the output of my index to UVW called index to UVW if what's getting out here are actually X, Y, and Z coordinates? Yeah. So in computer graphics, if you are displaying now again you can again think about 2D textures, not 3D. So if you have an object with texture which you want to display in 3Ds, for example, a table, then you have a mesh, and you need to map the texture on the mesh. And for that, you use a coordinate system of the table itself. And that's called a UVW coordinate system. So that's the local system which tells you like its coordinates inside the mesh. So for example, this point is always 0, 0, 0. No matter whether if the table stands here or on the other side of the room. But then you have XYZ coordinates, which are according to the scene or according to the viewpoint of the camera. And what you need to do, like basically on every frame update, you need to, because if I'm watching the texture not like straight, but like from some angle, I need to find where my ray of light is coming in the XYZ coordinate and which UVW coordinate it's hitting in the coordinate system of the texture. So what we are doing here is, I mean, we will use the same coordinates for XYZ and UVW, but what we're getting here is the coordinate inside the texture. In this case, it's also inside a 3D texture. So if I have my 3D texture as a basis, then I say, okay, my particle is here. Then it takes the particle position wherever it was like in the scene and looks where would that particle be in the texture? And that already gives me the answer to the sampling issue, because if my particle, if I have just, I don't know, 10 points in my texture, and my particle is like somewhere in the, my particle is like 10 points, one from here to here, it's 10 points. So if my particle is here, I can say the UVW coordinate as a float between 0 and 1. And we say, yeah, you're like at the beginning, you're in the middle, you're in the end. Yeah. Okay, and since, like I said, I already have the textures prepared as textures, we can just use this index to UVW thing to get the correct samples from our texture. So what we will do now, we'll start with a completely new graph. And yeah, let's start with a new graph. So we create a visual effect and a new visual effect graph. I call it volume. And start editing this volume graph. So first thing I want to do is I want to define this maximum size of my graph, and I will make it the same as the maximum number of the particles in my graph. That's the easiest way to define it. I can scale it later. So let's say I want a box with 30 by 30 by 30 30 cubes. So here I define 3 integers. It can be either int as an integer or uint as an integer unsigned without a sign, because number of cells will never be less than 0. uint makes sense. So 1, 2, and 3. And I call them max x, max y, and max z. And if I open the details with this little arrow, I can also put some default values for them. So 30 by 30 by 30, like basically my random idea of how much. Then the spawn system. So this spawn system was giving me 16 particles per second. Maybe I don't want to spawn them one by one. I just want to spawn everything at once. So in a single burst. So you delete this, select this constant spawn rate and delete it. And add a new one, which will be the single burst spawn. And how many?
30.
30 by 30 by 30. But, so hey, cool thing, of course, in all these, you could write like 30 by 30 by 30. It will tell you. But what if I decide I want 20 by 20 by 20? So the best way to do this is to multiply these values and use them as an input here. So I create a multiply node, and the output will go to count, and as inputs, okay, I'll make it a bit bigger for you. So as inputs to the multiply node, I take the property x, y, and z. And now I can select the number of spawned particles from the outside of my script. The spawn system, the single burst spawn system also needs to be told when it should actually spawn the particles. It just doesn't do it automatically on start. So you have to connect it to an event that will trigger the spawn. So here from the start connection point, you find event, and the default event that will appear is already the onPlay event, and that's exactly what we want, so we don't need to do any further modifications. So when the effect starts playing, first thing that happens is that it spawns this number of particles. Okay? So I will leave it here. Just tell me when all of you have done it. Just drag from the start connection point to, yeah. Okay. Yeah. Okay. Yeah. So now we are spawning particles. Now this is something I was talking about it a bit to Volodya. Maybe you heard it. So the issue with the graph is that this capacity cannot be changed. Not even like I cannot select the capacity using any variables. I really need to put some number here. but it's just the maximum capacity. So if I don't fill it with particles, I'm wasting memory, yes, but I'm not wasting computing power. So I just have to think, like, what's the biggest system I will ever try to visualize here? And I guess something like, I don't know, 1 million particles, for example. So I just like randomly put 1 million here.
But be careful with it, because if your GPU doesn't have enough memory, it will like, if you input
Yes.
too big number, it will cause troubles. So in your case, maybe better just make it like 60,000 and that's it. That's safe.
Yeah, okay. Okay. You're right. Yeah. I mean, like these laptops actually look like all of them should be able to handle 1 million, but let's just start with 64,000. We can increase it later if you will have a bigger system. You can try increasing the number later, but like, yeah, this is a safe bet. Now we will not be setting any random velocity, so we delete this. We also will not be setting the lifetime because we want our grid, our matrix, our volumetric data cube to be present all the time. So we delete this as well. And instead, we will set the position. So set position, and the position will be set using this index to UVW graph operator. So I check here an unified operator. I don't find anything. Operator index to UVW. So operator index to UVW, it also needs this XYZ. So I can, for example, drag them from the blackboard and connect here. And also the particle index. The particle index was called get attribute particle ID. So I type in particle ID and I get this get attribute particle ID. We should also explicitly set size to 1, just that it will make our later calculations easier because the default is 0.1. So now each of the boxes is of the size 1. And this is scaling the number between 0 and 30 to 0 to 1. So this will result in boxes of size 1 being put into a box of size 1. That's not what we want. We need to make the boxes smaller so that they can fit in that big box. And the reason I've set the size to 1 here explicitly is that we know exactly what the size of the boxes should be. So then we can scale them because the size is just in, like, it says the size in all directions at once. But yeah, sorry. So here to initialize particle, we create a block called set scale. And with set scale, we can set the scale for each of the directions individually. And what will be the scale? It will be 1 over the maximum value, 1 over the number of boxes in that direction. Yeah. So for that, I have it's called reciprocal is 1 over x. I will need 3 of them. I will create 3 of them. You could also make like a single vector one, but let's stick with that. And again, I will connect the inputs here, and the outputs will go to the scale factor. So now my small cube is 1 over whatever I specify here, 1 over 30 in that case. The positions are correctly set for 30 by 30 by 30. And I also know that I'm spawning the correct amount of particles because I'm always using these. I'm always using the user set variables for that. So it's like generic enough for like different use cases. So the next thing we wanted to do was so yeah, now we have positions, sizes, and to visualize the data, we also want to put color there because that's how we will. Yeah, okay, so now I moved these blocks down. But just one thing, even if you don't do anything in the update function, the block has to stay there. If you delete the block and connect the output, connect the output directly to the initialize, like it will let you connect it, but it will not work and it will give you some weird errors. But we will continue in the initialize mode because again, as I said, like this will be a static scene. So here, let's add another. Wait. No. We add the color later. So now let's delete the output quad. And instead of that, put output cube again. Yeah. I don't know if we are using lit or yeah. So mesh, output particle mesh. And as the mesh, we select the cube. And the texture, again, we need to find the white texture. So white 1 pixel should be the texture. Yeah. And we can put this thing to our scene just to test that it's working before we continue with adding the color. So maybe we will be like, I don't know, 10 minutes over time. Or like, as you wish, we can also just like stop here and continue tomorrow. But
Let's test first.
yeah, let's test it. Let's see. Okay, so I'll test mine and then I'll open the graph for you again. Don't worry. So that was this. I drag it somewhere here.
Okay.
I have absolutely no idea.
It's one big cube.
What?
Even if it works, you will see it as one big cube.
That's true. That's true. So what can I do?
Add opacity.
Yeah, okay. I mean, yeah, okay. I see it as one big cube. And okay, at least I can see that the cube has a size 1, and it has. That's a good thing. But I will want it bigger, so I want to set the scale to something huge. I don't know, like 50. But okay, like you should see one big cube of size 1 by 1 meter. Yeah, you're right. Like you could also make the cubes a little bit smaller. So after doing the reciprocal, you can like multiply it by 0.08 or something, and then it will give you some small distances between the neighboring cubes. Ah, like you have it at least. Yeah. It's there. It's a cube, yes. It's a cube. It's a cube. Oh, that's great.
Why is it a cube though? I thought
Well,
Because you created a lot of small cubes, don't have gaps.
Well, when I was setting up
it's a cube.
the objects, I chose sphere. So what is it?
The object, which object?
This one.
The mesh?
As
You've chosen a sphere as a mesh?
yes.
Okay, zoom in.
Sphere.
Zoom very closely. Zoom very closely to the cube.
So it's gonna be a number.
Zoom very closely to the cube. You see, it's a lot of small spheres. Okay, so let's get the colors in. So what we want to do now is we have this UVW coordinate, and I said this is a coordinate inside the texture, and that we will be sampling this 3D texture in order to get the color. So we'll be setting the color of our cubes. So here again, find set color attribute. And now we need to get the color somehow, yeah? And
It's in particle, right?
Hmm?
In the particle down.
in the initialized particle, yeah. Or like more correctly, you could do it in the update particle, because for example, if you would be changing the texture to get an animation, then you want this to be in update. But I mean, if we have time, we can do it like this tomorrow, but like so set color. And how we get the color? We need to sample from the texture. So we create a node, and if you look for sample, there's sample texture 3D. And that's doing exactly what it says it's doing. It's sampling a 3D texture. And the texture is supposed to have up to 4 values.
For a 4-dimensional texture.
No, it's a 3-dimensional texture, but it has the color is RGBA. These values are the values of each element. I mean, of course, you can look at these as another dimensions on its own. So like you're operating on a 7-dimensional object. 7-dimensional objects are not unusual at all. Like position, velocity, and charge, 7 dimensions. The Vlasov equation is a 7-dimensional equation. That's why it's so difficult to solve. So, and that's why it's also better to cut it into these 3 spatial dimensions, where the inner dimension has like some small particles, and each of the particle holds the additional 4 dimensions. And that way you go from this Vlasov equation in plasma physics into particle in cell method in plasma physics. You see, everything is connected. So we have the UVW coordinate. That's really this UVW coordinate. So you can just grab here and connect it here. And you've seen that the texture was all red. And that's because in my texture file, I only had one number. So I saved it as one color channel. And that was the first one, the red channel. So you can directly connect X to X. Now you need to get the texture here. So one option, of course, would be here to select this volume texture. A better option is here to add texture 3D as another property. Call it something, I don't know, volume data, yeah. That's a good one. And then we will connect it from the outside, yeah? So the texture, then you make a connection again, for example, to the empty space. You select properties, and it just gives you the only thing that can fit here, and that's this volume data 3D texture.
Does it have any benefits over just taking data from the volume tab and?
Well, yes, because because you can change this from the inspector, and you can also change this from the script.
It adds extra fields to the
Yeah,
interface.
yeah.
So
Look, if I now save this, okay, this has some color or whatever. Yeah, because and I found the okay. You see that data? I drag and drop this here. It's probably some conversion missing. So play. It should read in the texture. And you see that it's somehow, some colors are there. Maybe the other ones were probably not set to 0, but to 1. But like I see the outside as a thick cube. I would like if I go inside, the colors will change with the individual boxes, but it's probably not what I wanted. I probably wanted to have those cube partially transparent, right? So I go back to the graph. Back to the graph. Back to the graph. Almost there. And what I will add here is another operator, set alpha. Okay. So first I set alpha to something. Okay, this seems like 0.05 seems like a good value. Now it can be it should be partially see-through. Yeah. And last modification. So now you see that we are only operating on a single channel. Yeah. So we can like, of course, if I if I go back, I can change the graph. So the other channels are 1. If I change them to zeros, the thing will be like in shades of red. But you know from scientific pictures that usually you use some color scale where the colors actually go, I don't know, something from like blue to red or something like that. And for that, I also made this so this value to color map. Value to color map is a small So in goes a single floating point value, and out a color made of 3 components, which and it scales the values. Is this like default color map, which goes from blue for low values to red for high values, and which has a lot of problems because it's like, I mean, you shouldn't use it in your scientific papers because it has many issues, but it's the easiest one to implement, so I put it here. So we can use this operator. We can study it later if you wish. We can use this operator directly in this volume graph like this. So here I connect X because I'm getting the single value in. I get the value to color map operator, and out goes a full color. Again, okay, like this. So if you do this, then you already see that I'm getting those the values of those single numbers converted to something from blue to the shades of red. If I reach the yeah. So instead of going from the texture directly to one of the color channels, I go from the texture because I know, and this is something that I know because I am the one who made the texture. So I know that the texture only has this single number in the red channel, and I want to convert that single number using this value to color map operator from my Telegram group.
Yeah, I understand, but how we put it in this graph?
Oh, the same way as any other operator. So you can either just like grab here to the empty space and then find it like this, value to color map, or you can right click and create node and again look for value to color map and you should get it here. Yeah. Last fancy thing you can do, you can also modify the alpha channel so that the lower the low values will have low alpha, so they will be almost completely transparent, and the high values will have high alpha, so they will be more visible. Again, you can just base it on this single number you're getting. So here we will add multiply alpha. So we set some baseline alpha and we multiply it directly with this element. Again, you need to know at least approximately what's the range of this, so that it's more or less between 0 and 1. But if you do it like this, then just like let me know when all of you have the graph, so I can switch back to the scene. Okay. Yeah. No? Need some help? Yeah.
Which colors should we see now? Should we be seen? Yes.
Your size. The is huge. So go here. Make yeah. Okay, no. So
It was small.
put one, put just one there.
It is very small.
Oh, you're using spheres instead of cubes still?
So I should try using.
No, it's okay. Show me how small it is. It's like really too small, or like what? You need to save the. Yeah, this is okay.
No,
You
so
need
now
to
we
scale
can-
the whole thing. So select the volume object.
Yes.
Yeah. And scale it here, the whole thing.
Hmm.
Length exactly, like by 10 or
Oh.
so you can walk inside. Yeah.
I just couldn't see it and then increase the size, but
Yeah.
it's too demanding on the computer.
It is. Like especially the transparency is like something that's usually compute heavy. Of course, if it's like really too hard on the computer.
Now it works.
Yeah.
Now it works well and can be.
We
Because
can also decrease these numbers. So instead of 30, go for like 10 by 10 by 10 or something. Yeah.
but when it's the size of 100, it's some weird things starts happening. It looks like a big number of strings, so more like lines instead of.
Because you have those are like kind of like it's like an optical trick because like at some point you will have like some edges aligned on one line from the point where from the point of view of your eye or your camera, and like that will make some repeating structures in there. It's like you don't see that in the nature because usually because in order to see that you would need those things like absolutely perfectly aligned. But like if you do something absolutely perfectly aligned, like some artists, for example, use it. Like if you put if you made a box of mirrors, and you would walk inside the box of mirrors. Then if they are like precisely aligned, and then you would see those like wavy repeating effects at some points where like the reflections align with like the multiplied reflection. Yeah, it then looks like you're looking at lines, but you're really not. It's like just the the best way to visualize it is actually to make cubes which are a little bit smaller so that there's spaces in between those cubes. And if you don't like the effect, a good way to break it is to put some small randomness on the size of each individual particle. Because then you're breaking the correlation of those exact points, and like it will never be perfect. But got it somehow?
Different color.
No, that's it. That's the thing. I mean, yeah.
I mean, I see.
Okay. This is also influenced by the lighting you have in your scene. Yeah, so you will play with this tomorrow a little bit because you will also see like there are some parasitic effects that make it not look like extremely nice. You will want to get rid of them at some point, but like you can already use it like this. Yeah. So. Oh yeah, we have the multiply alpha here. So I will save it, close it, and this is my visualization of some electronic structure. I can walk through it. Now, again, I'm doing many things at once, so I probably won't put this stuff into a scientific visualization project, probably also not the wooden floor, yeah? In a proper scientific visualization project, I think this thing will be on a completely black background with like nothing inside, an invisible Vulkan plane, and I will just like use the VR headset to look around, or like maybe not even walk on a plane, but find some way to fly through the space. So that's it. Tomorrow we will add for the scientific visualization part. Tomorrow we will add this option to have a slice. So one slice of the cubes will be like more visible with higher alpha, and the rest will be with lower alpha. And we will use the VR controller like to move the slice around. So that's like really some interactive scientific visualization thing. We will also put everything in VR, and we will do something with the 3D scans you will bring, and till the end of the day, but how long you will want to stay, we will start putting the stuff in the VR headset and try it out in VR. And yeah, if you will have some ideas of what to try, then we can just like stay here and yeah, work on that. Okay.
And if you have your own data,
Yeah.
especially in the format which is similar to this, like cube format or something like that, try playing with that. If not, send it in the group chat so that we take a look at it and try also, then we together try adding it to the scene.
We can also try Googling for something interesting in the cube format.
Yeah, but it's interesting to look for your own data.
Yeah,
But of course,
exactly.
you can Google any cube data, or you can use some of your calculated band structures from OLAC courses.
Mm-hmm.
Сегодня